All right. Continuing with 16a, I'll just show you guys a few. Okay, let me ask you guys a quick question. What are the two main conditions for a function to be considered a PDF?
Has to be above x,
Above, yeah.
x equals 0.
Above y equals to 0. So above the x-axis,
Yeah.
right? And then Emily, what's the second condition?
Error equals 1.
Error equals 1. Very good. Okay, so for let's say for this question here, for example 2, right? I think last week we went past quite a few exercises. I think you guys got up to around question 6, which was the okay, I'll redo question 5. Yeah, okay, we'll do exercise number 5. All right, and then we'll move on to number 6, which is the new one. Do you guys remember the limit as x goes towards infinity, finding area? Yeah, as x tends to infinity. Remember the last topic from last week? Okay, I don't think you guys have done much of that. So that's why we'll do a bit of revision on exercise number 5. Okay. All right. Okay, let's go to number 4 and 5 actually. So get your paper out. I want you guys to try out this question first, question 4. Okay.
Can I borrow a pen?
Sorry?
Can I borrow a pen?
Yeah. Hang on. Do that. Here. Got this pacer instead. Alright, try this one. So what's the idea behind this question 4? And this is chapter 16a. Okay, what's the idea behind this question, Sahab? How do we find constant k?
It's a antiderivative with bounds of 0 and 2.
Okay, yes, antiderivative by the boundary 0 and 2 of the function, and then? What about it? So you get towards like the final answer will have k in it, right? But for it to be a probability density function, for it to be a PDF,
Error is equal to 1.
which means, what do you write here? How do we continue here?
Equals to 1.
Yes, equals to 1, okay? So because we know that this is a PDF, that's why we can say that this is equals to 1, okay? And then solve for k. All right, get your paper out and try this one. Okay, so knowing how to get up to this point is already a big head start for you guys. We're gonna try to work this one out.
Can I get some pages?
Yeah. That's good. I'll give you guys some time to get started first, and then I'll work through this question. So Suleiman, if you're listening to this recording right now, you should try out this question as well, and should aim to work it out fully before continuing to watch my explanations, if you can. Yes, that's right. Okay, negative 11 over 6. Did you get that one, Emily?
Oh no, I forgot to antiderive.
Big mistake, alright. I have to continue. Next question. Chance to redeem yourself. Question 5 here. So I'll do the first part, so you guys need to copy down the answer for part A. Okay, so normally you need to work out part A yourself, but I'll work that one out for you guys. So looking at this one there, right? The first question is sketch the graph of y equals to fx. How do we sketch this? What kind of graph is this? What kind of graph is this?
Cubic.
No. Well, yes, it's the cubic equation, correct? Yep. And how do we sketch a cubic equation? Yeah, something like that. Yes, right. Something like this, right? Now, looking at this, the first thing you should notice is that this is already factorized. You see, it's like a factor there and then a factor there. So for question A, the first thing I would do is set that equals to 0, finding the x-intercepts first. Okay, so I'll find the x-intercepts. All right, and that would be, so sub 0 equals to fx, so that would be 12x squared times 1 minus x, which means using the no factor law, you've got 12x squared equals to 0 or 1 minus x equals to 0, which means on this side, divide both sides by 12. Well, 12 times something squared equals to 0. That thing must be equals to 0. Okay? Yeah? And then this one will be x equals to 1. So we've got the two x-intercept, which is 0 and 1. Now let's just have a look at the graph, right? So 0 and 1 here. These two are the x-intercept. What do you think the graph looks like between 0 and 1? What would you guess the graph to look like? Would it be like that or would it be like this? The top one. Yes, you would guess it to be the top one, right? Because otherwise it will not be above the x-axis. Okay, yeah, so that's my guess. If you want to test it, you need to make sure that the turning point is at the top one as well, is also like a positive point. And how do we test for turning point? How do we solve for turning points? How do we find turning points?
Just do derivative equals 0.
Derivative equals to 0, yes, but I'm not going to do that. We just need to sketch it, because normally when you see a sketch like that, it's like, this one is like a mixture between a calculator and non-calculator. So this first part should be a calculator one, so for you guys, just need to copy over the graph, right? And then now for part B, how do we find probability x is less than 0.5?
You have to sub 0.5 into the antiderivative of the equation.
Yep, what are the two limits? So anti-derived from?
0 to 0.5.
Yes, that's right. So probability x less than 0.5 just means the area that is less than 0.5, right? So that would be this area here. So this is actually already the answer for C, you know? Shade the region which represent the probability. That's literally just the answer for C there. Okay, yeah? So I'm just giving you guys the answer again, then we'll move on. But yeah, so this one will be antiderive from 0 to 0.5 of the equation 12x squared 1 minus x dx. Okay, so when you antiderive between these two limits, you get the probability between, well, for x less than 0.5. Yeah? Okay? Now, try it. Work this one out. Emily, make sure you empty the right, huh? Did you guys get 5 over 16?
Yeah.
Okay, did you get that one, Sahar?
No.
What'd you get?
Something else.
You got it's basically the answer of big F 0.5, right? What's your 3?
1 over 8. Because then I made this the antiderivative x to the power of 3
Times into, yeah, that's
times
fine.
3 minus 4x.
It's 3x minus 4. It's 3x minus 4. Not 3 minus 4x. I think your mistake was when you do.
So then I increase the power by 1 so it's over 3. Then
This is 3x power 4. Total divided by 4 is 3.
Oh,
And then total divided by 3 is 4.
I did cross instead of up and down.
Yeah, no. So this one you're supposed to cancel out 12 and 3, right? So
Okay.
just total divided by 3 is 4. Total divided by 4 is 3. It's just a simple simplification of fractions, yeah?
Yes.
Okay? Alright, go back, fix that later. Okay. Now, so that's just to recap you guys on some of the basic concepts. Now we'll touch on example 4. I'll show this one again just in case you guys have forgotten from last week, and then you guys have to try out one of the questions that looks similar to this. So this question is about using the using the limits, because this graph doesn't have an upper limit. Okay, so sketch a graph of f, right? So remember for question A, we did this one last week. So this one, there would be a reflection in the y-axis, right? So normally it's like that, but because of the negative 2x, there's a reflection in the y-axis. So it sort of looks like that. And then when x equals to 0, f of 0 would be 2e power 0, which is 2 times 1, which is 2, right? So then the graph will cross through the y-axis at the point 0, 2. Okay, make sense? But then it will keep on approaching the x-axis towards infinity. It does not touch the x-axis and does not end. Okay, which means that, and then this one is only valid for x is more than 0. So I have to re-graph it. Right, the point here is a hollow point, and then the graph will go like that. Okay, and then on the left hand side it will be 0 for the left hand side here. You remember this one? Yeah, because of this one here, fx is 0 when x is less than or equal to 0. Right, so the y value is 0 for x to the left of 0, and also including 0. Does it make sense? Yeah. Sure? Sahal? Okay, you sure?
Yeah.
Alright, next is how do we show that this is the probability density function? Yes, error equals to 1. Now, how do we calculate the area, knowing that the area will extend forever? It will start here, but then it will keep on extending forever. It doesn't end. Alright, so how do we calculate that area if it doesn't end?
I think just the rest of it minus 1. I think something minus 1.
Not quite, that's a different concept. That's question C. Okay, that's question C. But for question B, you need to, so think about it, right? So you need to enter the graph from 0 to infinity, sort of. But you can't enter the graph to infinity. Infinity is not a number. So you can only consider, you have to put in the value A. You see, remember this one? Put in the value A, and then you find limits of. Yes, that's right. So you can only consider what happens when A goes to infinity, but you can't substitute infinity. It's not a number. Okay, so that's why you calculate this limit of and then enter the graph for 0 to A of 2e power minus 2x dx. Okay, make sense? But note that this means that this is the limit of this entire thing. Yeah, so lim is a function of that entire thing. All right, you're not multiplying lim or anything. Remember, limits from unit 2. Okay. So to calculate limits, you need to keep the lim there. So lim a to infinity of, then the rest you can just work it out as usual. So this one would be anti-derived, so that would be divided by negative 2. So that would be negative e to the power x, calculated from 0 to a. Okay, make sense? Just anti-derive it and then sub the limits in. Right?
How's x?
Sorry? Oh, yeah, my bad. It's negative 2x. You're right. Alright, so e to the power anything is the same. So then now that would be lim a to infinity of, you sub the values of a in, so that would be negative e to the power minus 2a, and then minus minus is a plus, right? Plus e to the power sub 0 will just be 0. Okay, make sense? Well, next would be, so now you have to convert this version here into a fraction. Why do we want to convert that to a fraction? Well, because when a goes to infinity, if you have minus 1 over e to the power of a really large number, and the other one's just 1, right? As a goes to infinity, this thing goes to 0, because negative 1 divided by a really big number, right? Really big number would just be approximately 0. Does it make sense? It would be like negative 0.0000. It's really, really small. Okay, so as the bottom goes towards infinity, 1 over that big number will just be approximating 0. Okay, so then you can calculate the limits at this point, and that would just be equals to 0 plus 1, which is 1, right? And then make the conclusion here. Remember, so make the conclusion since fx is more than or equals to 0 and total area, right? Total area equals to 1, fx is a PDF. Okay, remember this statement? You have to write the statement in your final conclusion because they're asking you to prove that it's a PDF. Okay, and how do we calculate PR of x more than 1? Hint, use what Emily said earlier.
1 minus the probability of x equal to 0.
Not quite. So remember, Sahab, this is a continuous random variable. You got the right idea there, but it's a little bit different. So we need to find the probability of x is more than 1, right? So that would be 1 minus what probability?
X more than 1.
No. More than 1 is 1 minus probability of x between what values? Because remember, so think about the shape that looks like that, right? Looks like that, yeah? And then you want the probability of more than 1, which means you want this area here, right? What's the remaining area that you can subtract, that you can easily calculate and then subtract from? Right? Remember, probability of more than 1 is technically this shaded area there, right? And that would be, and the total area would be 1. So then that shaded area is the total area 1 minus what area? Minus this thing, which is the probability of
1.
0 less than x less than 1. Yeah, the area from 0 to 1, essentially, right? Does that make sense? Yeah. So this one is, think of it as this one is area right of 1, right? To the right of 1 is equals to the total minus area to the left of number 1. Does it make sense? Right? Area to the right plus area to the left of 1 is equals to 1, right? So area to the right is 1 minus the area to the left. And area to the left of 1 is your probability of 0 to x to 1. X between 0 and 1. Make sense? Yeah, and what's the area of what's the probability of 0 less than or equals to x, well, less than x less than 1? This one would be 1 minus n to the right of, yes, 0 to 1 of what was it, minus of e to the power 2e to the power minus 2x dx. Okay, so then that would be 1 minus, and then anti-derive it as usual. You already anti-derived previously, so we just copy the answers over here. Negative e, that'll be negative e to the power minus 2x from 0 to 1. Note that because of the minus there, right? 1 minus, right? You should keep the minus there and then work out the other, everything else in the bracket first. So that's minus e to the power minus 2, and then plus e to the power 0. Okay, so at this point, then you open the brackets and then multiply the negative 1 in. So that will be 1 plus e to the power minus 2 and then minus e to the power 0. Make sense? Yeah, just distribute the negative sign in there. And e power 0 is just 1. So 1 minus 1 is 0. So that was just e to the power minus 2 is the final answer. Okay, and this is the probability of x is more than 1. Okay, make sense? Yeah. Are you guys ready to try it out by yourself? Okay, redo this question. This is example number 4. Okay, redo this example number 4. Okay. Tell me if you need me to scroll up and down, but redo that on your sheet. So Suleiman, if you're listening to this, you should retry this one as well. Yeah, you should be able to you should aim to be able to recreate this example perfectly, and then we'll move on to the exercises.
Well, do we ever deriving y?
What do you mean? Derive y?
So I saw somewhere it's like do it as a thing. It's like a concept where you derive y as well. We're driving in terms of y as well.
Yes. We will have to do that. Yes. Yeah, but that's actually one of the harder questions. It's the one where it's like it's using the Leibniz notation. This is a bit advanced. It's not related to this topic, but for example, it's just saying that if you have dx over dy equals to, let's say, 2x, right? So let's just say y equals to x squared, right? Then dx over dy equals to 2x. Then dy over dx is just 1 over 2x. It's like, you can think of it as, because you're flipping these two, right, to get dy over dx, is you also just, flipping this between the
Because when
fraction.
I saw it was like when he derived y, I think it was 2xy, he derived it normally, but then he added a dx over dy next to it.
Yeah, this is, sorry, it should be dx over dy. Yep.
Yeah.
Yeah. So if you want to work that by itself, right? So this one would actually have you, so x would be positive. Okay. This one is a bit strange because then you would get x equals to square root of y, or x equals to negative square root of y. If you were to change it up and make x a subject, yeah. So that would be y to the power 1/2, and that would be y to the negative y to the power 1/2, right? If you were to go dx over dy, then and then you substitute the y value in, you substitute the y value in, you would get technically the same thing. Does that make sense?
Yeah, no, yeah.
Yeah. So that's why you would find dy over dx, and then you just flip that around to get dx over dy instead of like trying to make x a subject.
Yeah.
Okay, because this one considered as 2x over 1. Yeah, you can flip the Leibniz notation, and then you get the answer.
Yeah, because it was also like deriving when it's like 2xy and stuff like that. So yeah, because that just seemed a bit harder.
Yeah, that's a bit harder, but we won't do that anytime soon. Yeah, don't worry about it. Yeah, you guys will get a chance to practice that closer to the exam. Okay, once you have done all the basic concepts, that's like something that may or may not come out, so I'm not gonna bother too much with it. We'll do all the main concepts first, which is example 4. Right.
What do you see?
C is you can use the idea that area to the right of 1 is 1 minus the area to the left of 1. And then the area to the left of 1 is between 0 and 1, and to the right between 0 and 1. Okay, did you get e power negative 2? Okay, then start on question 6. So I'll give you a hint to get started. To find a constant k, the total area equals to 1. Alright, and total area, remember it starts from 0, is the same as empty deriving from 0 to a value a, and then you need to calculate the limit as a goes to infinity. Right, because there's no limit, right? There's no limit for the y value, so that's why you have to just go to infinity and then you write this one dy, and this area must be equals to 1, and then you solve for k. And then b is a lot easier. Alright, make sure you get the antiderivative right, and then you sub in all the values.
Isn't it divided by what?
By negative 1. Because the coefficient of y is negative 1.
Oh.
Alright, that's why it turns into negative k. Okay, this is a complex familiar question, so many things can go wrong. Just be very careful with every single step. Okay, the answer for k is that it's just equals to 1. Okay, and let's see if you can do question B. B should be easy. Okay, that's a hint for you. B should be easy. Now, before you guys get started, right? Let me ask you guys one question first. So They ask you for question, they ask you probability of y less than or equals to 2. Now compare that with y is just less than 2. Is there any difference?
It includes 2.
Yeah, but is there any difference between the two answers? Is there a difference? The only difference is that this one is equals to PR of y less than 2 and then plus PR of y equals to 2, right? That's the only difference, right? The one on the left hand side, this one here has less than and equals to, right? But is there a difference between the two answers? No, why? Why is this actually the same? Even if they ask you to less than or equals to 2 and then you write equals to 2, there's no difference. You both will get you will get the right answer anyway. They will not mark you wrong. Why? Why are they the same? Why is this the same as just less than 2? What is the equal? Like what happens to this one?
0.
Yes. Okay. Sorry, this one should be equals to 2. Yes, this one is equals to 0. Emily, why? Why? Why is probability of y equals to exactly 2? Why is that 0?
Because like they'll have many decimals but not exactly 2.
Correct. Okay. So this is the same as saying probability of equals to exactly 2.0000, and for this number to happen is basically equals to 0. Right? So probability of x equals to exactly 2.000, like a whole number 2, and the chance of that is 0. It's like saying the probability of your height being exactly 178 without any decimal place, right? 0.000, the chance of that is almost infinitely 0. There's no way you're going to be exactly that high. Alright, so that's why the probability of the continuous random variable taking an exact value is 0, and that's why using the less than or equals to or just the less than symbol, they are the same in continuous random variable. Okay, if it's a continuous scale, then it's the same. In a discrete one, remember how you could have 1 failure or 2 failures or 3 failures, then it's not the same, right? Because at least 3 failures means 3, 4, 5, 6, 7, 8, 9, 10 failures or successes. Okay, make sense? Right, so in the continuous range though, they are both the same. Okay, so just to recap you guys on this idea and then continue. How do we find PR of y less than equals to 2? Or I can just write PR of y less than 2. It's exactly the same thing. Alright, so what would this one be?
Anti-deriving balance.
From 0 to 2, correct. And then k is 1, so that'll just be e to the power minus y dy. That's it. If you got the first step right, then see if you can get the final answer right. Hi, did you guys get 1 minus e to the power minus 2?
I got.
Is it?
Yep.
Oh, minus minus. Yeah, so that's a plus, and then the first one has a minus. Yeah, because when you antiderive it, remember you haven't antiderived it. You have to antiderive it, so that'll be this thing and then divide by minus 1 because negative 1 is a coefficient of y.
Okay.
That's dy by the way. Because you derive with respect to y. Okay? Or antiderive with respect to y.
Oh, is it negative e to the power negative 2 plus 1?
Yep, that's right. Or 1 minus e to the power negative 2, same thing. Okay, alright, let's move on. So let's give you guys a chance to do that question. Let's move on to the next example. Now this one is another layer of complexity, right? A different kind of complexity. So we're not dealing with infinities, but we're dealing with conditional probability. Do you guys still remember the formula for conditional probability? Okay, conditional probability. What's the formula? PR of A given B equals what? Conditional probability, right? Probability. Okay, so probability of an event A given an event B is equals to
probability of A intersection B over the probability of B.
Yep, A intersection B over probability of B. Perfect. Emily, remember this one? Yeah. So intersection means what? And or or? And, yes. This one means A and B happening together. Okay, because intersection, right? It must cover both A and B, right? So yeah, so that means A and B. So let's see how we work out this example 5. And once again, just see how I work it out first. Try to understand it because you have to redo this example before you go to the exercises. Okay, exercise is very similar to this one, so you gotta just redo this one first. Okay, so question A. So this is the time in seconds is a random variable x with the density function given by this thing here, right? Then find the probability that the student takes less than 12 seconds. So what they're asking is probability that the x value takes less than 12 seconds. Okay? Yeah? And this would just be what? N to the right from 5 to 12. Because remember, it starts from 5. Okay? From 5 to 12 or 5 over x squared dx. Now, for conditional probability questions, I would prefer to use the big F notation because look, later on you have limits of 8 and limits of 10. Okay, so you've got limits of 12, 5, 8, and 10. There are 4 limits. I prefer to use the big F notation. So let's calculate big F. Big F of x, right, would then just be, so this is an antiderivative. So later on, you guys will learn something called the cumulative density function. That's a CDF. It is a little bit different from just an antiderivative. Okay, so I'll tell you guys in advance. So don't be confused when you get to that point and you're like, what? Okay, let me think. Yeah, okay. Let's use the big F notation. So an antiderivative big F would be antiderive this one there, right? So Sahar, what would be the antiderivative of this thing?
That would be negative 5x to the power negative 1.
Yes, that's right. Now, okay, maybe try this. Let small g of x equals to 5 over x squared. So I'm using a different notation, okay? So trust me on this, use a different notation, right? Call that function gx. Because remember, fx is a PDF, which means it has 2 conditions, right? It has, when x is more than equals to 5, it will be this equation there. But then when x is less than 5, it's just 0. So it will cause it to have like at 5, it would be like 0 before, and then after would be like something like that, right? Or probably something like that. Okay? Yeah? And that is why you want to just call the inner function, like that one there, just call that gx. So then you can calculate big G of x, right? So then this one you can write it as 5x to the power minus 2. So add 1 to the power divided by the new power is what Sahal said, negative 5x to the power minus 1, which is negative 5 over x. Okay, any question there? No? Okay, so how I know you've been using the big F notation, but from now on, try to convert that to call a different function, gx first, and then use big G. So capital G instead of a capital F, because later you will learn something called capital F inside the PDF in this chapter towards, I think towards the end, I think might be next chapter.
So you just change the letter?
Yeah, change it to a different letter. Trust me, you will learn like big F means something a bit different in this chapter. Okay, so just change to a different letter because we're saying that gx is just that function without any notation. You see how gx is just that function, but there's no limit. There's no, oh, x is more than equals to 5, then equals to this, but then x is less than 5 is. So it's basically not fx. Okay, because fx, think of it, another way to think about it is fx is a piecewise function, right? You can't technically calculate big F of x because that would also need to be a piecewise function. There are 2 conditions. The first one is for x is more than 5, and then it will be x less than 5. Does it make sense? Yeah. So if small f is a piecewise function, big F also has to be a piecewise function, and you will learn that a little bit later. And that's why just cast the just the actual like x function to a different variable g, and then you can just use the antiderivative big G of x correctly. Okay. So I'm just being very nitpicky because if you guys develop the wrong habit now, it's very hard to fix it later. So do this. That's why I'm stressing on this one. But yes, so now we need to calculate big G of 12 and 5, right? So then big G of 12 would be -5 on 12, and then big G of 5 would be -5 on 5. Okay, so this one should be -1. All right, so then probability of x is less than 12 is equals to big G of 12 minus big G of 5. Okay, make sense? Emily, do you remember this concept? Saying that big G is an antiderivative, right? And then you're just substituting the two limits in. That will be big G 12 minus big G 5, right? So technically this one just equals to big G of 12 minus big G of 5. Yeah? So instead of antideriving here, I want to antiderive it separately and then sub in the values separately. Okay? So then that would, and then let's just get back to that point then. So practice writing that after this. But yeah, so that would be -5 on 12, and then minus -1, which is +1. Right? So this one would be then 7 over 12. Okay? So this is the probability that x is less than 12. Now, so that's the first part. Next is, have a look at question B. Find the probability that the student takes between 8 and 10 seconds. Given that he takes less than 12 seconds. Alright, so let's write this out in the conditional probability format. Question B. It's the probability that x is what? Between 8 and 10. Right? So 8 less than x less than 10, given that x is less than 12. Okay, make sense? Yeah? The probability, so we want a conditional probability that the x takes a value between 8 and 10, given that x is less than 12. Okay, so think of it this way, right? The total probability is like it goes to infinity, right? That whole one goes to infinity, right? But then from 5 to 12, so this is the little bubble from 5 to 12, right? That's the area from 5 to 12, right? Because the other area outside of that will be 12 to infinity. Does it make sense? Yeah, because this shape there, this equation, if you were to sketch it, that would be at 5, that would be 1, and then it goes to infinity like that. Okay, it will be like this equation. It will look something like that. It's similar to how we work out the other ones before. Make sense? Yeah, and that's why the area from 5 to 12 would be just part of the area from 12 to infinity, right? Like the whole area should be equals to 1. So this outside area, so 12 to infinity, right? The total area must be equals to 1. So they're saying that what's the probability that's between 8 and 10? So see how this is 5 to 12, right? 8 to 10 is actually within the 5 to 12. So okay, actually maybe I'll write out the formula first. So that will be PR of 8 less than x less than 10 intersect with x less than 12 over probability of x less than 12. Okay, any question here? Right? I'll just highlight for you. This is event A, that's event A, and this will be event B, so that's event B. Okay? It's just probability of A given B, and A is just between 8 and 10, and probability of B is less than 12. It's the same as probability of A and B over probability of B. Okay? It's just a conditional probability formula. Any question here? Sahar? You sure? Emily? You sure? Okay, alright, I'll continue. How do we resolve this condition on the top here? How do we resolve that? What's the technique?
I mean, we have the 7 over 12, so...
Well, not yet. Don't look at that one yet. Just resolving this one here. How do we find 8 to 10, right? So 8 to 10 and less than 12.
The line.
Yes, the line thing, correct. Okay, so you will in order to work this one out, to work this one out, right, we need to draw that line thing. So then we have the values here, 8, 10, 12. 8, 10, and 12. So first we draw 8 to 10. Means what? From here to here, exclusive, right? Okay? And then next is less than 12. Less than 12 is what? From here and then goes all the way back. So what's the overlapping area? 8 to 10, that's right. Okay, that's the only overlapping area between these two lines. Make sense? And that means that the top area would just be probability of 8 to 10. So 8 less than x less than 10 over probability x less than 12. Does that make sense? Yeah? It's like on the number line. So think of it this way, right? The area from 5 to 12 is so for on the number line 5, 6, 7, 8, 9, 10, 11, 12, the area from 5 to 12 will include the area from 8 to 10. Does that make sense? Right? Because 5 to 12 is like the whole thing, right? And then you want 8 to 10 out of that, so that would be like a smaller area. So this smaller area would be 8, 9, 10. Or between 8 to 10. Well, it's not exactly 8, 9, 10 because it's supposed to be continuous, but yeah. So that's from 8 to 10. Okay, and then the bigger one would be from 5 all the way to 12. Make sense? Yeah. So it's the smaller area divided by the bigger area, and that's why we've got that one there. So this one would just be big G of 10. Remember we use G, we cast the function to G, so we can use G. So big G of 10 minus big G of 8 over, and then the value on the bottom is what we found earlier, 7 over 12. Okay, and on the side, you can work out big G of 10 easily, right? That's just big G is, you see, we already found that over here. So big G of x is just this one, negative 5 over x. Okay, so that's just be big G of 10, which just be negative 5 over 10, which is negative 1 over 2. And then big G of 8 is negative 5 over 8. Yeah, that's it, can't simplify that. So then that would be negative 1 over 2, minus is a plus 5 over 8, everything over 7 over 12. And when you divide by a fraction, it becomes? Yes, times by 12 over 7. Okay, and then in the brackets, you need to make the denominator the same, so that'll be minus 4 over 8 plus 5 over 8. Make sense? Yeah, and then that would be 1 over 8 times 12 over 7. What's next?
6.
Sorry? No, you don't multiply straight away. Remember, when you simplify, yes, divide by 4. Yes, so that would be 3 and that would be 2. So that would be 3 over 14. See, much easier. Right? You don't need to simplify 12 over 56, that takes longer. So before you multiply, always simplify your fractions first. Okay? Make sense? Yeah? So that's my working. If you look at the textbook working, it's really short, but it's a lot harder to figure it out. Because actually, they just skip a bunch of steps, now that I think about it. Yeah, this just skips a lot of steps. So now I want you guys to retry this example. Okay, this is a really difficult one, all right? Example number 5, retry this example. So I will change this one up into... Okay, so anything in, except for like the obvious explanation stuff, anything that's written in blue and red, you have to copy them down into your answer. Well, not copy, but write it in as your answer. Any question? Okay, start working. Example 5. This is one of the harder ones. Work through this one. I'll leave the answer here, but yeah, work through it. Try not to copy the answer down if you can. Only just glance at it from now and then. Oh yeah, Suleiman, if you need to access the answer, just go to the notes. Okay, or you can skip ahead and go back to the part, the previous part of the recording if you're listening to this. try using the big G notation, yeah? Because otherwise the other question will be a lot longer. Okay, look, if you don't want to use the big G notation, something you can do is just remember when you do, for example, later on, enter the rank between, was it 8 and 10? Right, so 8, 10, it's just, yeah, in question B, see, the probability that it takes between 8 and 10, right?
How do we do it again?
Yeah, so you have to do the antiderivative again, but just remember you have already done that before, so you can just copy the answer. So technically you can use the square bracket still, but
Okay, let's use it again.
yeah. So in order to use the big G, just yeah, okay, yeah, that's fine. You can go with that. Yeah. So normally you have to define the small g first. Yeah. So define small g of x, call that function gx, and then you can write big G. Okay, nice. Start on question 7. Right there. So makeup is the condition, yeah? The condition will and each other, not the probability. So look at the formula. It's probability brackets 8 less than x less than 10 and x less than 12. But it's only one probability. Because you see you do probability and probability, that doesn't make sense. It's probability of this and that condition.
Oh, so it's
And yep. Should be less than that, not equals to, but yeah, it doesn't really matter.
what's that? This one?
Yeah, because the question is less than, there's no equal to in the question. Right? You sure? Between, yeah, it doesn't matter. Yeah, it's the same thing. Yeah, it doesn't matter.
PR
Mm-hmm.
x smaller than less than 12.
Yeah. So now you do the big G of 10, big G of 8.
Oh.
And for that, you need to resolve the solution. So practice drawing the line. Drawing the line and resolving it. Yep, perfect. Keep going. Finish that. Should get 3/14 and then start on question 7.
Wait, we're meant to expand the brackets.
Yes, you're supposed to expand that, otherwise you can't antiderive it. Alright, so for question 7, I'll give you guys the graph first. Just focus on the other one. So the graph is between 5 and 11. So 5, 11, and it looks something like that. Okay, just a quadratic equation. Alright, so that's a graph for question 7. And see if you can find out. So that's A, so just do B, C, and D.
Wait, when antiderive from B, do we do bound from 0 to 7 or 5 to 7?
Within 7 days means 5 to 7 because it starts from 5. So this one they already gave you this small f function. You can use the big F notation straight away for this one. Or you can call it a different function too, that's okay.
Wait, wouldn't there be an ln in this?
No, there's no ln. This is a quadratic. So it just, when you antiderive, it just goes to cubic. Because 1/36 is just a number. So guys, note that when you're antideriving it, when you're deriving it, when you're modifying it, the 1/36 is just sitting out there out of the bracket. It's just a constant number.
Okay.
Alright? So if it's just a constant factor, leave it out. Then when you antiderive, you can just ignore that and times it back in after. So these techniques are quite advanced, alright? But it's very important when you're doing harder questions. Actually, I think for this one, right? Okay, I'll save you guys the trouble of the algebra. Use your calculator. Okay. If you have a graphics calculator, I want you guys to try. Okay. Actually, yeah. For this one, use your graphics calculator to solve it. So when you're finding the antiderivative, don't even antiderive it. You just use your graphics calculator to solve it.
We anti-derived it, so.
That's okay. Just leave that one. Redo that. Just redo that part using a calculator, graphics calculator. It will be a lot shorter because I'm looking at this and I'm like, you can work it out by hand, but it's too long. It's not worth it. Okay, so I will actually redo this one using the graphics calculator instead.
I mean, I do have the big value right now, so.
The big G?
No, so I think the biggest value, because it's t cubed, so it's 7 cubed, which is 343.
Yeah, I mean, you can keep going, but use your calculator. Yeah, you can use your calculator to assist you with this one.
Okay.
Yeah.
Which question are you doing?
Question 7. So Emily, if you haven't started question 7, right? When you're working through it, just use the graphics calculator. Because you can do the antiderivative of a function straight away in a graphics calculator. Yeah, I think this one's just way too long. It's not worth it to do the tech-free version for this question. So Emily, if you bring your graphics calculator out and just punch this thing into the graphics calculator.
I can bring it through.
You can bring it today? Yeah, use this one. Yeah. Okay. I'll pause you guys after question C. Okay, so work up to question C, and okay. Alright, so Suleiman, if you're listening to this one, try to get all the way up to question C. We do that up to question C, and then take a short break. I'll pause. I'll end the first half of the recording now.